In the previous class, we are discussing about ammonia molecule. We have discussed the preparation and properties of ammonia. Now in this class, we can discuss about the oxides of nitrogen. We know that what are the oxides of nitrogen, what are their colors and their properties are. The magnetic character and the properties. Magnetic character, we know that if there is an unpaired electron, they will be having a magnetic character. So if we discuss about that, the oxides of nitrogen, so we used to say that the oxides of nitrogen are oxides of nitrogen. We can say that the oxides of nitrogen are N2O, NO, we write that N2O3, then we can write that it is NO2 and N2O4 as well as N2O5. So these are the oxides of nitrogen what we have is. So let us discuss what are these oxides of nitrogen, how we are going to prepare them and what are their structure and all. The structure we can discuss all of them together. So all the structure we'll discuss together, but we can discuss about their properties, their nature, like that we can discuss here, the preparation and all. So if we talk about the preparation, we'll write that first. We can write that it is dinitrogen oxide. It is called dinitrogen oxides. Oxide. So the dinitrogen oxide that is prepared as, so we'll write that the preparation when ammonium nitrate is heated, then it gets converted into the N2O plus twice of H2O. So the dinitrogen oxide is generally prepared by this method. Obviously, if we say that it is, we say that the dinitrogen oxide is that is a neutral gas. So we used to write that this is the preparation. What we have is, it is a neutral gas, neutral colorless gas. Colorless gas, we used to say that, right? It is a neutral colorless gas, we used to say that, and then when it is heated with, and when heated with copper, that is copper, we get like this Cu, that is reacts with the N2O, it gives that CuO plus N2 gas is liberated, like that. So when it is heated with copper, it will show that property like this, that is a colorless gas, and when heated with copper, we used to get like this. Similarly, we used to say that it is diamagnetic in nature because it doesn't have the unpaired electron. So it is diamagnetic in nature. It is a diamagnetic gas, magnetic gas. So that is one of the oxide of nitrogen. Another oxide is nitrogen oxide. That is a nitrogen oxide gas. So the nitrogen oxide gas, if we have to prepare this, we can prepare when the copper is heated with, we used to say that when the copper is heated with dilute HNO3, we get that NO gas. So we get that copper heated with HNO3, that is dilute HNO3. I got that, it will be forming that copper nitrate. NO3 whole twice, I'll get that, plus that is NO plus, we'll get that, it is like this. We can balance that, as well as I'll get that H2O. So we are going to get this as like this. So we'll get that the N factor of this is 2, the N factor of this is plus 3 to plus 2, I'll get that it is 3, so thrice of this, twice of this, I'll get that copper, thrice of this, twice of this, and the water which will be formed here is, that is balanced. So that is how we are able to write that the nitrogen oxide is formed, as well as we can say that when nitrogen oxide is also formed when the HNO3 is treated with FeSO4 in presence of dilute H2SO4. So we also get that. Or you can directly react that this is A method, we can write that. The B method will be when NaNO2 is treated with FeSO4 in presence of, that is H2SO4, that is H2SO4, that is dilute H2SO4, we used to say that. Then in that case also we get that is Fe2SO4 whole thrice. Fe2SO4 whole thrice, we used to say that. So twice of this, then thrice of this, and we get that it is plus Na2SO4. So I require that one more H2SO4 in this plus NO plus H2O is formed. So that is how we get the product of the reaction and we get that 4H2O. So that is how we get that the product of the reaction is the NO is formed. Twice of NO is formed in the reaction. So that is how you get that nitrogen oxide gas in this case. So the nitrogen oxide gas is liberated in these cases. So that is how we are going to write that the nitrogen oxide gas, which is formed in the reaction. So if I write that the properties, I'll write that it is a neutral colorless gas. Neutral colorless gas. So it is a neutral colorless gas, we can say that. And we used to write that it is a neutral colorless gas. If we talk about the property of that gas is, then it reacts with halogens. So it reacts with halogens. It reacts with halogens. That is NO plus X2 it gives, that is NOx. Reacts with halogens like chloride, fluoride, that is the reactivity with halogens is. So it reacts with, mainly it reacts with chloride and bromide, where mainly it is X is Cl or Br. We used to say that. So that is the reaction. What we get is with this. And also we used to say that if it at high pressure and temperature it gets converted to. So at high pressure and temperature, NO at high pressure and temperature we used to say that it gets disproportionate into N2O plus NO2. So it gives a disproportionation reaction like this in N2 and NO2 is. It is paramagnetic in nature and is paramagnetic gas. So it is having a paramagnetic character because it has an odd electron in that on that nitrogen atom is. So that is how we can write that and the temperature will be high, that is around 50 degrees centigrade. Not very high, it will be high but not very high. It is around 50 degrees centigrade what you used to write. Third we can write is, that is we can say that N2O3 is. So dinitrogen, we used to say that the N2O3 is, that is dinitrogen trioxide gas. So we write that dinitrogen trioxide gas. So initially we used to say that it is a gas, but we say that it is it is formed as when NO and N2O4 are mixed. So we used to say that when NO and N2O are mixed, we'll write that the preparation method, how that preparation is. When NO and N2O4 is mixed, we get that N2O3 in this. So we are going to balance that, that is twice of this, I'll get that twice of this. So that is how we get that N2O3 is. It is a blue solid and acidic in nature. It is a blue solid and acidic in nature. It is a blue solid and it is acidic in nature. The gas which is present is a blue solid. So at high temperature it will be in a gaseous state, but it is a solid at room temperature. So we get that it is a blue solid is formed in this case. So you can also write that if this is a method, we can write like this also, that is N2,4NO plus O2, you'll get that it is twice of N2O3 is formed. So you can get that the reaction is like this. That is also formed in the reaction. That is how the preparation method is. The properties, you can write that N2O3 react with KOH to form that. The properties we can write that. That is the N2O3 will react with KOH. It reacts with KOH to form KNO2 in the reaction. So it forms that KNO2 plus. So KNO2 plus will get that. It is H2O which will be formed in the reaction. So that is H2O which will be formed. So it reacts with the base because it is acidic in nature. So if it is acidic in nature, we are going to write that the reaction of this will be with the base is. So it will react with the base. Even it reacts with the N2O3 reacts with HClO4. form a salt that is NoClO4, that is a salt which is formed plus water. It is going to form a salt like this. It means that it reacts with a strong acid like this to form the salt like this. So it forms a salt with H2SO4 and HClO4. So I'll react this with H2SO4 to form the sulfates. So if I write that N2O3 when reacts with H2SO4, then in this case it is going to form NOHSO4, that is a sulfate, which is formed plus water is formed in the reaction. So we are going to write like this. So that is how we can write those reactions of this to form the water is. So these are the three oxides. The next oxide we can write is NO2. So that is called nitrogen dioxide. In the oxides of nitrogen, we can discuss about the nitrogen dioxide. Now, in this case, you can see that this is a diamagnetic gas. It is diamagnetic in nature, N2O3, because there is no odd electron in that. Now, I can write that NO2. NO2 is nitrogen dioxide. So, I'll get that is NO2, that is nitrogen dioxide. So, it is nitrogen dioxide. We used to say that. The nitrogen dioxide, it is, we'll say that the preparation method now. For the nitrogen dioxide, we can say that. So, you treat with, that is copper with the concentrated HNO3, you'll get NO2 gas, which will be liberated in the reaction. So, I'll write that. The preparation methods. Even if you react any non-metal with concentrated HNO3, the liberation of NO2 will take place. So we used to say that when copper is treated with HNO3, then it gives CuNO3 whole twice, plus I'll write that it is NO2, plus I'll write that it is H2O, which will be formed in the reaction. So if I write that it is copper, that is NO3 and NO, I'll write that thrice of this, then I'll get that it is thrice of H2O that will be formed in the reaction. So that is how the reaction is. So we got that the nitrate is copper nitrate, we get the reaction is like this. So it will be balanced because this is twice, then we should write this as 4. So we get the twice, now it is balanced because we required the twice of H2O. And it is balanced the reaction because n factor of this is equal to 2, whereas the n factor of this is equal to 1. You multiply by 2 because that we'll get that half NO2. So we can write that the reaction is like that, or you can write that the decomposition reaction of nitrates. So lead nitrate, when it is decomposed, we know that on decomposition of nitrates, the decomposition of all nitrates except that alkali metal nitrate and the inert metal, that doesn't decompose to form oxides. Otherwise, most of the nitrate, they form lead oxide, that is metal oxide plus NO2 plus O2. That is how that NO2 is. It is a brownish gas. That is a brown gas which is formed in the reaction. So we can write that it is acidic in nature. It is a brown gas which is acidic in nature. So we can write that the brown gas which is acidic in nature is formed. It is a brown color gas which is acidic in nature. It is a brown color gas, acidic in nature. It is paramagnetic. It is paramagnetic, like that we can say that. It is a brown gas which will form a colorless substance because what happened? Write that, or you can write directly that it becomes colorless. Colorless. If we say that twice of NO2 will be in equilibrium with N2O4, that is a solid, we say that. So this is a brown gas and this is colorless solid. We used to say that. So it becomes colorless when it is getting solidified at room temperature. So that is a colorless solid, we can say that. So this was how we can discuss about that the nitrogen dioxide is. So this is about the nitrogen dioxide, we can say that. Now if we talk about that its chemical reactions, so chemical reactions are like this. The chemical reactions of NO2 when it reacts with that is NO2 when reacts with fluorine, it gives that NO2F. That will be formed like this. When reacts with fluorine, fluorine, it reacts like this. Right like this, that is NO2 with Cl2, it is going to form that NO2Cl, and with HCl, if I write that with that is fluorine, NO2 when reacts with HCl, it is going to form that the NO2 with HCl, we are going to write that it is NOCl. So it will form NOCl plus, we'll write that Cl2 plus, can write like this, that is N2. That is how the product of the reactions are. So, and we can write that, not N2, we'll write that H2O. We'll get that. So, NO2 when reacts with this, we get that H2O and 4HCl. Yes, so we get like that. So, these are the reactions, we can say that. And even it will react with, because NO2 is acidic in nature, but it reacts with CO, which is a neutral gas, to convert into CO2 plus NO. Because the stability of NO is more than the stability of CO. That due to the difference in the electronegativity, we say that this is no doubt more stable, but there is a formation of CO2 also, and its formation of NO is endothermic phenomenon. So we say that even it reacts with carbon monoxide to convert into the carbon dioxide, and nitrogen oxide is formed. So it is acting as an oxidizing agent there for carbon monoxide. This is about that NO2 is. Next we can write that N2O4. N2O4, we know that how it can be formed. You can write that N2O4. It is because of the dimerization of, that is NO2, it will get that N2O4. So it is a colorless solid. We used to say that. So then we can write that is Dinitrogen Pentoxide. So I'm going to write that N2O5 Dinitrogen Pentoxide. So Dinitrogen Pentoxide is, that is, so dinitrogen pentoxide, we used to write that is prepared by, you can directly write that by dehydration of, because we can write that the dehydration of HNO3 first, we can say that. So if I react HNO3, that is a preparation method I'm going to write. So HNO3 when dehydrated with P2O5, it converts into N2O5. Plus I get that H3PO4 is formed in the reaction. So that is how we can write that. This will be twice. I'm going to write this as twice. So not only this as twice, I'll write this as 4 times. 4, so I'll get this as that is twice. So that is how we are going to write that the balance reactions. So we'll get this as thrice of N2O5. So that is the balance reaction. What we get in the reaction is. So that is how you're able to form that H3PO3. You can write that directly, that thrice of HPO3 is. You can write like this also. So we get that P2O5. That is how we can balance the reaction is. So P2O5, or you can take P4O10. So that I'll get that thrice, I'll get that H3PO4. Now you can add water to form that, because that should be a dehydrated product. H3PO4 will react with N2O5. So we should get that. That is a metaphosphate. Metaphosphate. And this is anhydrous nitric acid. Anhydrous nitric acid. So that is how we get the product in the reactions are. That is how the preparation is. We can say that. So the preparation can be like that. We can say that at around, obviously it will be around 250 degrees centigrade. What we get the product is. So that can show the dehydration. Next we can write is its properties. So it will be like this. The properties we get is, the properties, obviously it is a colorless solid, we say that, acidic in nature, colorless solid, acidic in nature, colorless solid, acidic in nature. It is diamagnetic, no doubt, and is diamagnetic. That is, we say that it is diamagnetic in nature. So that is how we can write that the compound is. Then N2O5, no doubt, we write that the chemical properties, that is, we can write that this is one. The second chemical property, we can write that about the chemical properties, that is N2O5 reacts with the sodium metal. to form NaNO3 plus NO2. NaNO3 plus NO2 is formed. It means that it forms that the oxidation state remains same, plus 3, 2, plus 3. With water, it will get hydrolyzed and form that product like that. On hydrolysis, the oxidation state never changes, we know that. Next we can write is, we can say that the acids what we get is N2O5 when reacts with water, we know that when on reaction with water, the oxidation state never changes. So we used to write that N2O5 will form HNO3. And when we treat that, that is N2O5, when treated with, we used to say that it is NaCl, then what I got is, again I will get that NaNO3 plus NO2Cl. NaNO3 plus NO2Cl is formed. So that is how I can write few chemical properties of N2O5 is. So these are few chemical properties of N2O5 is, and N2O5 is also used in nitration of benzene and all. So these are the reaction of N2O5, we can say that, and that is about the oxides of nitrogen. What we required is, these are the oxides of nitrogen is. Next we can write that structure of oxides of nitrogen. So we are going to discuss that. The structure of oxides of nitrogen. If I read the structure of oxides of nitrogen, I am going to write like this. Oxide of nitrogen. So we are going to write that the structure is like this. So N2O. For N2O, I am going to write that it is like this. Triple bond N, the lone pair on this, the lone pair on this, and a coordinate bond with oxygen. This, or you can write like this. N triple bond N, oxygen, a negative charge on this, a positive charge on this, a lone pair on this, we can write like this. This is one of the structure of N2O. Next I can write that NO. So NO can be written like this. NO can be written like this, and then we can write like this, or you can write like this. Or you can write like this. The odd electron bond is present in that. So this will be the structure of that is NO is. Now you can write the third one. That is, we can write that for that is N2O3 is. So N2O3 will write like this. That is N double bond O, the coordinate bond with oxygen, and the lone pair is present there. Or I can write that it is O double bond N, O double bond, that is O, like this. This is unstable. This is stable structure. So there is an unstable structure, and this is a stable structure. What we are going to write is, then we can write that after N2O3, this will be unstable because of these lone pairs, no? Repulsion between these, among these lone pairs, what they are present there. So it will become unstable. This bond will become unstable. Now we can write that the fourth one is, we can say that NO2. NO2 will be like this. The NO2 structure will be like this. That is the structure of NO2 is. The structure of NO2, or you can write like this, doesn't matter. You can write that structure like this. That is odd electron on that, oxygen, a negative charge on this. The positive charge on this, you can write that, or double bond O, you can write like this. So that is for the NO2. And we can write that for, that is N2O4, that will be nitrogen. You can write like this, that is a coordinate bond on this, a coordinate bond on this, and a double bond on this. That is N2O4. And last we can write that is N2O5. So the N2O5 will be like this, that is the tetrahedral structure will have the two lone pairs on this, and the nitrogen which is having, that is a coordinate bond like this, double bond O. I am going to write that it is double bond O and the coordinate bond like this. So that is the structure of the N2O5 is. These are the possible structure what we have in N2O5 is. So these are the structure of N2O5, and we can have that is the structure of N2O5S. We can say that. Now we know that if we talk about the bond angles, in this case the bond angles, because there is only one electron, I'll write that it is greater than 120, because the only odd electron is present there. So the bonding is around 132 degrees. Here it will be 180 degrees. It is sp hybridized. Obviously, we'll say that this is sp2 hybridized. Here we'll write that it is more than 120, so I'll write that, but it is sp2 hybridized. This is also sp2 hybridized. This is also sp2 hybridized. So these are sp2 hybridizations that is present. So sp2 hybridization means we'll say that their bond angle are nearly, that is in this case the bond angle is around 135, whereas in this case the bond angle is around 134. So the bond angles are almost same in these cases. This is around 135. That is all. So we'll say that nearly same bond angles is present in this. So we got that the bond angles are like that, and we'll say that it is, but due to that planar structure, this is a planar structure, no doubt, because this is that is 112 degree. It is a planar structure because sp2 hybridized. So we used to say that it is a planar structure. This is also planar structure. This is also planar structure. This is a linear structure. This is also a planar structure. sp2 hybridized, that is a linear structure. We know that sp hybridized, so it will be linear structure. This will be linear structure. We used to say that. So these are the structures and the preparation and the properties of these oxides of nitrogen are. So the oxide of nitrogen, their properties, their structure, how they are, we are able to discuss that. So that's all about the oxides of nitrogen, what is required for us. So that is about the oxides of nitrogen is. Now we can discuss about that the nitric acid. So we are going to discuss the nitric acid now. What is nitric acid and what we have to discuss in the nitric acid? Let us check. So we'll discuss about the nitric acid now. We can discuss about the nitric acid now. HNO3, how we are going to discuss, and what is the requirement of that nitric acid, what we have to discuss is. So let us check that what is the next oxide. After oxides we can write that it is the fourth one, that is nitric acid. So nitric acid, that is HNO3. So we are going to discuss that. Nitric acid, that is HNO3 we have to discuss is. So nitric acid is a strong acid, we know that. So nitrogen forms oxo acids, such as we can say that nitrogen forms the oxo acids. The oxo acids, such as we used to say that oxo acids, that is some is mono acid, some is right now. So we'll write that the acids are HNO3, that we say that it is right like this, that is the oxo acids of nitrogen. I'm going to write that. What we say that is, this is a nitric acid. Then I can write that remove one oxygen, you'll get nitrous acid. This is nitrous acid. Remove one more oxygen, I'll get that HNO. This is hyponitrous acid. But HNO molecule doesn't exist freely. So it is in this form, it exists freely as a dimer. So this is hyponitrous acid. But if you add H in oxygen in the nitric acid, then it is called pernitric acid. Pernitric acid. So these are the oxy acids of nitrogen. So the oxy acids of nitrogen are these, we can say that. Now we can write their preparation of nitric acid. So we can write that what are the preparation methods of nitric acid is. You know that. How we have written the names of the nitric acids are. So we know that how we have written the names. From nitric acid, if you add one oxygen in this, you'll get pernitric acid. If you remove one oxygen, you'll get nitrous acid. And if you remove one more nitrogen from there, it is called hyponitrous acid. But hyponitrous acid exists as a dimer. So that is called hyponitrous acid. So we can write like that. Next we can write is, we are going to write that as the preparation methods. So if we treat that, the preparation method, first we can write that the lab preparation methods from the salt of nitrates. So first I can write that lab preparation methods. So the salt of nitrate when treated with the H2SO4, so the potassium nitrate or sodium nitrate. NaNO3 when treated with the H2SO4 because there's a sulfate. Right now the sulfate of the sodium or potassium are more stable than the nitrate of sodium and potassium. So I'll write this as H2SO4. I'm going to get that as Na2SO4 plus HNO3. So the product which is formed in the reaction is nitric acid. That is a lab preparation method. So when these two reacts with this, we'll get the proper product which is nitric acid, and the sulfate of those are formed in a glass retort. So when it is heated in a glass round bottom flask, we'll get that the reaction is slow heating. It is not very high heating. It is on slow heating. We'll get the product like that. But the commercial preparation method is by Ostwald process. Commercial method, we used to say that method by Ostwald process. By Ostwald process, we say that. So the commercial method is by the Ostwald process. In the Ostwald process, what happens? We used to write that Ostwald process, the ammonia is treated with oxygen. So ammonia when treated with O2, it converts into NO plus, we used to say that H2O. So we can balance that very easily. That is, we require the excess of oxygen gas and ammonia, that is on this nitrogen oxide gas, and water is formed. So we can write that. That is, we'll get that you can write this as twice of NO. We can write that. So we can write that 4NO, so that we can get like this, and you'll get that 12. So you'll get that 6H2O is formed with the reaction. So that is how we can balance the reaction. 4 plus 6 it is 10. So we get that reaction like this. Now the catalyst used in the reaction is platinum, or that is platinum gauge is used. Then the temperature is around, we used to say that 500 that is Kelvin, and 500 Kelvin and 9 bar atmosphere, or you can say that 9 barometric pressure or atmospheric pressure, one and the same thing. Now what happens, this nitrogen oxide which is formed in the reaction is treated with oxygen to get converted into nitrogen dioxide. So that NO which is formed with the reacts with oxygen, or you can say that here to get converted into this NO2 gas. So this NO2 gas when treated with water, we used to say that H2O, we get that it is nitric acid. So HNO3 is formed in the reaction. This is how we get that nitric acid is. HNO3 is formed in the reaction is. So this when treated with water, we can say that steam, you can say in gaseous state, we get the product as that is HNO3, and that is aqueous, and we get that plus NO is formed in the reaction. So NO is also formed in the reaction. So we are going to balance that as we can say that H2O plus twice of NO. So I got that twice of HNO3 plus we'll get that NO in the reaction. It gets disproportionate. So we are going to write that this will be plus 5. So it will be 1. This will be, that is plus 2 to plus, that is plus 4 to plus 2, it is twice, so 2 and 1, we get that, and we can write this as thrice. So we get that the product of the reaction is like this. So the product of the reaction is like this, we can say. So this is reused. This formed is reused in the reaction. That is how we can write that. So you can have just balance by plus 5, n factor is 1. This is 4 to 2, n factor is 2, you multiply by 2, multiply by 1. Total nitrogen is thrice, so I have written thrice. Now how many hydrogens are required? 2 hydrogens, so I will write like this. So that is how 617, so we get 617. That is balanced reaction. So that is how we are able to write that how the nitric acid is prepared by the Ostwald process is. The HNO3 which is formed in the reaction is 68% pure, right? So NO formed is recycled, we know that, and HNO3 is concentrated by distillation. So after distillation, here we can say that the HNO3 formed in the reaction is concentrated by distillation up to 68%, is concentrated by distillation up to, we can say that, up to 68%, because at 68% it forms azeotropic mixture, that HNO3 68% and water, that is H2O, that is 32%, is azeotropic mixture. Tropic mixture. Now it cannot be that is dehydrated by distillation. It has to be dehydrated by, that is the highly concentrated. Now the water present can be removed by using concentrated H2SO4. By using the concentrated H2SO4, and we get 95% pure HNO3. So the HNO3 we get in the laboratory is the 68% HNO3. So we used to say that further concentration from 95 to, it can be 98%, 95 to 98% pure HNO3 we get by that. So that is how we are able to write that. Properties, we can write that, the properties of HNO3, we can say that, properties, we can say that, of HNO3. Colorless liquid, it is a colorless liquid, it is a colorless liquid, obviously HNO3 is a colorless liquid, we used to say that. Freezing point of 231 and boiling point of 355. So freezing point is 251 and boiling point is 355 Kelvin. That is the freezing point and the boiling point is. We won't have to remember that easily, that we won't have to remember that what is the boiling point and like that. The lab grade HNO3 is, the lab grade HNO3 is 68% by mass. 68% by mass of density because it is 68% by mass, so it will be having a density of 1.504 gram per cc. Consider centimeter cube. So that is the lab grade HNO3. In gaseous state, HNO3 exists as a planar molecule. In gaseous state, HNO3 exists as a planar molecule. We can say that. Exists as a planar molecule. So we can write its structure like this. That is H, O, N, double bond O, and it is like this. So it is a planar molecule. We'll get the two lone pairs on this. So it is all the atoms are present in the same plane in the gaseous state is. Concentrated HNO3 is a strong oxidizing agent and reacts with most of the metals. Concentrated HNO3. HNO3 is a strong oxidizing agent. Right? We used to say that it is a strong oxidizing agent and reacts with most of the metals. Most of the metals, except we used to say that the inert metals like, except, that is gold, silver, we used to say that, platinum, like that. These are the metal which doesn't react with HNO3 is. So with these, the product of oxidation depends on the product of oxidation. The product of oxidations depends on, obviously it will be on the concentration. It is a dilute or concentrated, depends on the concentration, temperature, pressure, etc. We can write that. So it depends on these properties, that is concentration, temperature and pressure, like that, and the nature of material undergoing the nature of material undergoing the reaction, undergoing the oxidation reactions. The oxidation reaction, we used to say that. So that will depend on that also. So if we write that what are the reactions, what it shows, we can write that reaction of HNO3 with that is the metals are, we can say that because HNO3 react with metal to give, because concentrated HNO3, if it reacts with any metal or non-metal, the concentrated HNO3 will always liberate NO2. But in case of dilute or very dilute in some cases, in case of dilute it gives nitrogen oxide. But in case of concentrated it always forms NO2 gas. In case of dilute it forms NO. But in some cases it also forms ammonium nitrate or that is N2O. So what are the cases? Let us check that part. How we can predict the product of the reactions in those cases. So in some cases it forms that ammonium nitrate, whereas in most of the cases, as I have told you, that if it is concentrated, I am going to write that it is always a, if it is concentrated, it is always a NO2. So we'll write that part in a table. Let us say we'll write in a table that what are the metals with concentrated HNO3, how we get the product of the reaction is. So with concentrated, as I have told you, that doesn't matter it is non-metal or metal, it always liberates NO2 gas. So we'll write that reaction, that we can make a table, and then we can write that what are the metals present there and what are the products we have to remember for the reaction of concentrated nitric acid. So we can write that element which is going to react. So a reaction of HNO3 we are going to write. Of HNO3, I am going to write that the elements what are going to react, right, with the nature of HNO3. That is nature of HNO3 means dilute or of HNO3. Then I'll write that the product which is formed, and I'll write that no doubt that is the reactions also we can write. What are the reaction we are going to get as. So we can write that according to this we can make one table, and that is we can say that in the metals what we are going to write is according to the, we can correlate those metal according to the electrochemical series. We know that SRP values of metals. That is what I am telling is electrochemical series is. Now what we can do is, what we can write is, we can say that in this case that is, we'll write that it is suppose we are going to write the element as, we'll write that 1, 2 like that. So if we are having an element and I'm going to write that magnesium and Mn. So Mn, manganese and manganese. Nature it is, I'm going to write that cold and very dilute. So I'll write that it is cold and very dilute, HNO3. Then the product of the reaction in this case is, we used to say that it is metal nitrate. So in this case I'll get that metal nitrate as the reaction is, right. So what I've written is that magnesium reacts at that is HNO3, then they will get converted to MgNO3 whole twice plus hydrogen gas is liberated. That is what we are going to write is. So they are going to form the metal nitrate and the hydrogen gas is liberated. So we know that the strong electropositive metal will react with acid to give you that hydrogen gas in the reaction is. Then we can write that if suppose we are having that is zinc or Fe, they are little less electropositive metal, what we used to say is. So less electropositive metal, now in these cases there are different conditions. So very dilute, then we'll write that dilute, and then I'll write that it is concentrated. So in concentrated, you know that what you have to write is, in all these cases, in concentrated, you know that it is NO2 which will be formed always, the product. But in dilute, they are giving that N2O gas, whereas in very dilute, they are going to form ammonium nitrate. So the reaction in this case is, we are going to write like this, that is, suppose I'm going to write that zinc, and very dilute HNO3 is there. Then in that case, I'll write that is ZnNO3 whole twice, plus ammonium nitrate is formed in the reaction, plus ammonia gas will, that is, we can write that, plus we can write that the ammonium nitrate in the reaction, as well as the water is formed in the reaction. Obviously it will be aqueous, so we'll say that water is formed in the reaction. So we can balance that reaction, because the N factor, we know that according to the N factor we are able to write the balanced reactions. So this will be like this, that is 4, 10, you can write that 4 this, then you can write that ammonium nitrate, then you can write that it is thrice, then you can write the product of the reactions like this. So we'll write that 8 and we get that ammonium nitrate like that. So that is the product of the reactions. In case of dilute HNO3, again the zinc will react with dilute HNO3 to give you zinc nitrate and 2 and water. So it will react with HNO3. We write that with HNO3 to give you that zinc nitrate, ZnNO3 whole twice, plus I write that N2O plus H2O is formed in the reaction. So we can write that it is zinc and zinc nitrate which is going to react in that. So that we'll get that it is, we can write like this, HNO3. Here we are going to write this as 4, then I get that it is 4, 8 plus 2 N2. That is how we can get the product of the reaction. So you can write that is the product of the reaction is. With concentrated, the reaction products are almost same in all the cases. So with concentrated, the zinc will react with HNO3 to give you that as zinc nitrate whole twice plus twice of NO2. You can write that plus water. So here you can write that directly. It is nitrate NO2, so zinc nitrate, that is twice. We'll get that. So I'll write this as 4 HNO3 and I'll get that it is twice of water. So you get that the balanced reaction. So that is how you can write the reaction. So that is how you're able to write that reaction is with that zinc is. Next we can write is, that is the reaction of tin. With tin, you can write that it is dilute and that is concentrated. Similarly, I'll write that it is with lead. So if I write with lead, that is with dilute and concentrated, you can write like this. Similarly, I can write that is, so now we can write in this case. In concentrated, there is no doubt, we are having NO2. In concentrated, we won't have any doubt, that will be NO2. But in case of dilute, there will be difference. Tin will have ammonium nitrate, whereas lead will form nitrogen oxide. So the change in oxidation state depends on that electrochemical values, that is the reactivity of these elements. So if we talk about the reactivity of elements, more reactive elements liberate hydrogen, but the less reactive elements form with concentrated it is always NO2 which is liberated, but with dilute the products may change in some time. With zinc it is and Fe it is N2O, with Sn it is NO, that is ammonium nitrate, and with lead it is NO2. With Sn they are not forming the, right now, the NO2 gas in dilute, in case of dilute, because zinc and that is Sn, they are forming the ammonium nitrate in the reaction. So we can say like that. So we can write that the metals like that is, we can say that copper and silver. Copper and silver, again I can write that if the copper and silver are present, then in that case we'll write that dilute and B, that is concentrated, we can write that. So in case of concentrated, we won't have any doubt. We'll write that NO2 is there, but with dilute, they are forming NO. So the reaction, the elements which are present nearby hydrogen, their reactivity in the electrochemical series is less. So since the reactivity in the electrochemical series is less, then they form nitrogen oxide in the dilute, and the concentrated they used to give NO2. Similarly, if I write that mercury does not react with dilute. Mercury doesn't react with dilute. Dilute, no reaction. So mercury does not react with dilute, no reaction. Whereas in case of concentrated, it gives, obviously we know that in case of concentrated, what we have to write is, there is no exceptions. We have to write that in concentrated it is NO2 which will be formed. Similarly, I will write that in case of other metals like antimony and arsenic. So Sb and As, that is arsenic and antimony, we'll write that when it is a dilute, no reactions. Dilute, there is no reactions. Where it is concentrated, it will be, if it is concentrated, we are going to write that it is, with concentrated, we are going to get that it is NO2 which is liberated in the reaction. So we'll write that few reaction in these cases is, with antimony and arsenic, it forms acids instead of oxides. So in this case, suppose I'm going to write that the antimony and HNO3, the concentrated HNO3, I'll write like this. Antimony plus HNO3 which is concentrated, it is going to give antimonic acid. That is antimonic acid. As, that is, as we write that, antimonic acid plus NO2 plus H2O. So we can write that the antimonic acid is like this. This plus 5 oxidation state. So we get that like this. Plus we get that NO2 plus we get that H2O. Then we can balance on the basis of n factor. Because here it is plus 5, here it is 0. So you write that 5, the n factor of this is 5. Here it is N2 also, n factor of this is 1. So you can multiply with 1 with 5. You'll get that nitrogen as 5. The antimony is 1 and you can balance that reactions. So Sp, we can get that reaction as like this. That is 5 and we'll get that 5 NO2 and we get H2O. So 5 H2O, we'll get the 3 here, 2 here, that is 5. So that is how you can balance the reaction. In case of copper, you'll say that the dilute HNO3, you know that how to write that. Copper plus HNO3, we are going to write that. With HNO3 is copper nitrate we'll have, plus NO plus H2O we can have. And in case of this concentrated, we can write that HNO3 get converted into copper nitrate, plus we can write that whole twice, plus we can write that NO2 plus H2O. Then on the basis of redox reaction, we are able to balance that. Similarly, you can write in case of lead. In case of lead and zinc also, we are going to write like that. Zinc and lead, it will be the same reaction what we have. So it will be the same reaction. Instead of that copper, we have to write that lead. So write that Pb plus HNO3, you can write that it is PbNO3 whole twice plus NO2 plus H2O, and in this case you'll write that it is Pb plus HNO3. You know that how to write the reaction in that case also. So we can write that it is PbNO3 whole twice plus NO plus H2O. So on the basis of the redox reactions theory, you are able to balance that reaction. In case of tin also, you are going to write that Sn plus that is HNO3. You are going to write that it is SnNO3. So in case of tin, because tin forms, we know that if it is a tin, it will form stannic acid. So stannic acid plus NO2. So I'll write that in case of tin, it is H3SNO3 plus NO2 plus H2O. That is a stannic acid what we have. Stannic acid. And in this case, because tin forms stannic acid. Ammonium nitrate, as we have written in case of zinc, similarly we can write in this case also, as we have written in case of zinc gas. So the similar reaction, we can write that instead of zinc, we are going to write that Sn. So HNO3, we'll write that like this, we can get the balanced reaction. That is SnNO3 whole twice plus ammonium nitrate plus we get the triso H2O. So that is how we can write the balanced reaction for all these S. And here also we can write the same reaction with the mercury. So that is all what we can have is about that reaction product. This is the main part what we have to remember, that how we get the different product. In case of concentrated nitric acid, we get the same product always. Product doesn't change. So that is how we can write that the product of the reaction with the metals, the reaction of HNO3 with metals. With metals, you can say. So that is the product of HNO3 with metals. Similarly, you can write that the reaction with the non-metals, it forms the acid and we'll get the product like this. So I'm going to write that some reaction with non-metals. So the reaction with non-metals, you can write like this. The reaction with non-metals, we can say that. So with non-metals, then I'm going to write. Suppose I have I2, carbon, sulfur, like that. So if I treat this with HNO3, I'm going to get the product as, that is HiO3, the acid, plus NO2 plus H2O. That is the product. With carbon, I'll write that HNO3, I'm going to get this as CO2 plus NO2 plus H2O. Or you can write carbonic acid, it doesn't matter for me. So then with the sulfur, that is S8 with the HNO3, I'll write that it will be H2SO4 plus NO2 plus H2O, like that. And with phosphorus, I'll write that HNO3 will give us H3PO4, you can write that, plus NO2 plus H2. And we can balance the reaction by that oxidation number method, what we have. So, but in all these cases, what I have written is the concentrated nitric acid. Concentrated nitric acid, so that we can write the reaction like this. So you can balance these HNO3, you can balance on the basis of 0, 2 plus 5 like that. You can balance these 0, 2 plus 4 like that. So you'll get that balancing of redox reactions. You can write the balancing of redox reaction, but in concentrated nitric acid, we always get the NO2 as the product of the reaction. Doesn't matter it is metal or non-metal. The product will remain same in concentrated nitric acid. So these are the product of reaction. Now I wanted to tell you about that the brown ring test. You already know that. What is brown ring test? Ring test. We know that. In which the complex formed, in which the brown ring complex is, the brown ring complex is, complex what we get is Fe H2O whole 5 NO, and we get that as sulfate. So in this case, iron has +1 oxidation state. That is a brown ring complex is. So that is, and this NO also have +1 oxidation state. So we used to get that it is the brown ring complexes, and we know the reaction. We already discussed in the laboratories, and HNO3 is a very important acid which is used for making the explosives, and in many chemical reactions it is used. So that is about the nitric acid, what we can say is. So that is all about the nitric acid, what is required, and this is about the nitrogen, right? That is about the nitrogen and its compound is. So that's all about the nitrogen and its compound. In the next class we can discuss about the phosphorus. So this is all about the nitrogen and its compound is. So we can write that. Here you can balance on the basis of that what I have told you, on the basis of redox reactions. Know that how to balance the redox reaction on the basis of n-factor method. So that's all in this classes.